All right, so shut up. All right, so last class we I put in a little green here that we're kind of going to power through our web languages over here. So we started talking about Perl and PHP, and this kind of goes along the lines of where the internet kind of first came out, before it was really a thing. So you had a whole bunch of, Unix system administrators, people who are running servers for companies and things like that, who are now thrown into this brand new role of having to support internet stuff for their newfangled employees who wanted to take advantage of this new internet thing. Everybody thought they needed a web page, and they would just put up stuff for no good reason and things like that. So a whole bunch of people in industry wanting to dabble in this, and you had these system administrators who had all these other jobs going on, who now also had to support this new thing that they didn't know much about. All right, so initially they were having to support that with the tool they were already familiar with, which was Perl, and that tool was then kind of adapted to do internet stuff. So it's kind of like, you could fix anything with duct tape, almost that kind of approach. Maybe not quite to that extreme, but basically here's a tool that didn't even know the internet existed when it was created, and now we're applying it to internet problems. All right. Well, then as people got more and more familiar with writing web pages, and the internet became maybe more of a thing. I'm not even sure if it was necessarily destined to be what it is today at this point, but people were trying to create sites that had more complex things in them, and so a language called PHP came out, which there really isn't anything special about PHP in the big scheme of things, other than the fact that it has a lot of things built into it that people commonly do on the web. Okay, so just like you buy a blender has buttons on it, and it has things built in for blending, like making smoothies and stuff like that. That doesn't mean you can't make a smoothie by like duct taping a thing together and shaking it really long and really hard, and you eventually stuff will break up. Okay, it's just not built for that. Okay, so that's Perl. And then PHP is the blender. You just push the button. All right. So if I take us down to our PHP slide here, so we'll call this kind of the this is a web first language. So it's still a general purpose language, very similar to a lot of other programming languages. Nobody really uses PHP for writing things other than web things. But you could. If you really wanted to, you could use PHP for that. So its problem is it lacked something called MVC. We haven't talked about MVC yet, have we? Okay. That's okay. I'll talk about it right now. And so we'll talk about that in a second, but it also required this IT skill set thing where if you wanted to, even today, this problem still exists today. If you wanted to create a website and you wanted to do it in PHP, there are some tools now that allow you to kind of download a couple of things, install the right stuff, and then you can start working on it. But generally speaking, you can't just write a PHP program on your computer and run it. You need a web server. You need a plugin for that web server that understands PHP, so that when you send when you try to run your index.php file on the web page, it hits the preprocessor for PHP on that web server, runs that program, and spits out the HTML and JavaScript that's the output of your program, and that's what shows up on the web browser. It's not something you can just sit down and start writing, because you need to have the infrastructure set up to do it. So today, if you were going to write a PHP website, more than likely what you would do is you would probably get an account with like a GoDaddy.com or something like that, where $5 a month you can host a website. They provide you with a web server. They provide you with the PHP tools that to run your code, and then they provide you with a mechanism for you writing your code locally and uploading it there, or you can write your code up there and just save it there. All right, so they make your life easier for being able to actually start writing the PHP stuff, which goes way beyond the language itself. You need to have that IT skill set, because if you go back to the early days, at this point we're just saying you just need money. You have $5 a month, you can do PHP stuff. And there's some actually third-party things where you can download and run a little mini PHP server on your computer and stuff like that too, and that's free. But if you go back into the early days of PHP, you would have had to, if you wanted to just test it locally, you would have had to download like Apache web server, get it running on your machine. Then you'd have to download the PHP mod for it, for the module, and then you get that installed. Make sure it all understands PHP, all the things are talking correctly. And in the early days, those things weren't integrated nearly as well as they are today. Then you would actually test your code by writing some PHP stuff, running it through the server, and seeing it worked. So it required an expertise beyond programming. And one thing you run into, at least in computer, well, you see it in computer science, and some of you have, I think I've asked it before, about half the class is computer science traditional majors, and half the class is IT, something along those lines. Well, what you typically will have is there's going to be a separation. So when, let's look at maybe you as seniors or you 3 years out into industry. If you graduate with a computer science degree, probably you're going to have been spending most of your time writing software and things like that. You're not really going to be that person who's installing servers and configuring stuff and things like that. Even if you had this mentality that you were the geeky person before, and that was stuff that was, you were good at previously, the technology is going to pass you by. And it's not that you're not going to be capable of doing it, but you're going to have to go read a couple of how-tos or something like that for how do you configure the new stuff, the things that you haven't seen before. Similarly, if you're on that IT side of things, even though you were forced to take some programming classes in school and stuff, that's not going to be something you're going to be doing on a daily basis necessarily when you're in industry, and that stuff is going to be forgotten. So that if you actually get into a situation where you're going to have to write some code or something, you're going to have to give yourself a little weekend crash course or something like that to get back up to speed. So those skill sets get separated. So generally speaking, if we're going to say that the programming skill set is the person who's going to be trying to use PHP to write a site, yet they require that IT skill set to get the system up and running, that was pretty difficult for a lot of people. It's kind of the struggle there. Okay, so let's talk about the let's talk about MVC real quick. So we have something called design patterns. Have I mentioned that before? Design patterns? Okay. So design patterns are actually something you'll hear quite a bit about through your years in school, but it's always going to seem very vague. So a design pattern is a proposed good idea to a, quote, common problem. So already, just that definition sounds vague. First of all, actually, not good idea. Sorry, good solution. What does it mean for something to be a good solution? And then also, what does it mean for something to be common, for a common problem? So for instance, if we want to dumb this down, most of us in here at some point in our lives have made a peanut butter and jelly, right? Okay. Now there might be a couple of different approaches for what's the best way to make a peanut butter and jelly, right? These like jokes you see online and stuff like that. Some people, they want to put the peanut butter on first and they put the jelly on a second piece of bread, you put it together. Some people, there's 4 or 5 different ways you can make the peanut butter and jelly, right? And then you see that stupid stuff where they actually make the peanut butter and jelly in the same jar. That doesn't make any sense.
Oh, yeah.
And then you just scoop it out.
Yeah.
My dad's a cheapskate. He bought some of that.
Yeah, but that's not. But you get the wrong balance.
I know it's wrong.
No, it's a bad pattern.
It's really bad.
Yeah, you can't do it that way. You want to know the lazy way of doing this? here's the lazy way of doing this. Don't spend your time spreading peanut butter and stuff because that's going to rip the bread and all that stuff, right? So you just put a couple of clumps of peanut butter on the bread, and you put a couple of clumps of jelly on top of that. You put the bread on top of it and just smush it down. It'll all spread out in there. It'd be perfect.
That's what my dad does.
Yeah, it's.
You can rub it together like this too.
You're already eating at that point. I just smash the thing down until you get a little jelly squirting out the sides, and you know it's done. then you know it's done cooking. Some bites have a little bit more of one thing than another, but it's like yeah, it's perfect. All right, so punchline is that 3 or 4 of us in here could come up with a design pattern for how to make a peanut butter and jelly. And they might be very different. Yet we might all think that it's a good solution or it's the best solution for that. Now, what's interesting, though, is design patterns were kind of made for academics. So you've heard this phrase before, you perish or publish, or publish or perish thing. So people who are in academia were supposed to do research and write papers and crap like that. Oh, man, design patterns are perfect for that. All you have to do is pick some obscure problem. That's a common problem. And then suggest some solution that might be good, maybe not. Maybe it's good. And you're going to name it something weird. All design patterns have crazy names. You name it something weird, you publish the paper. Worst that happens, somebody says, yeah, there's a better idea than that. Oh, you're right. I still got the publication. Check mark. Done. Okay, so the punchline there then ends up being that there's a zillion design patterns. But over the years, a couple have kind of bubbled to the top as being popular ones, things that have held true, things like that. And one of them is this design pattern that they called MVC. And MVC stands for Model View Controller. So obviously that's self-explanatory. Okay, so they have the nice little acronym, then they have a name that doesn't really mean that much after that. Okay, so now we need to give some context to this. So Model View Controller says it's a good idea to separate your logic from your interface from your data in your software applications. All right, so if you forget about the data part of it now, because that's really talking about databases, and we just think about the logic from our interface. Whenever you use a computer program, the part of it that you're interacting with is the interface. Right now, I'm using Keynote, and I'm using its user interface. Now, we know there's a whole bunch of code and stuff behind there that's making stuff work, right? But a very important part of the solution is the interface. Now, programmers, diehard programmers sometimes will say, oh, as long as it works, it's fine. Well, if your code works, yet your interface is almost unusable, your program isn't all that great. Now, not all interfaces will be pretty, but they should at least be functional and they should be relatively easy for humans to use. As an application gets more and more complex, you can imagine that both the interface and the logic become more complex themselves, right? So you look at, Keynote here has a relatively simple user interface relative to like Microsoft Word. If you look at Microsoft Word, there's 50 different menu options. Each one has like multiple things that go inside of it because Microsoft Word's been around for a long time. And it's got a lot of updates to it and a lot of extra tricks and things like that it can do, most of which most of us don't use, right? But the interface for Microsoft Word is a pretty complex interface. Not that it's a bad interface, but there's a lot going on to it. The interface itself is a huge software application. Then you go behind the scenes to it and you think about all the logic that goes into making Microsoft Word work, all the programming stuff. In the early days of programming, a language like PHP, what you would have is you would have your interface, if we talk about web stuff. For the web, our interface is represented with HTML. So hypertext markup language, this is a little language that allows us to make our sites look pretty and that kind of stuff. All right, so HTML is the language we use for that. Yet our logic is represented with things like PHP or Perl or Ruby, things like that. So we'll just use PHP as our current example. Our logic might be represented with PHP. In the early days of PHP, if you looked at a page called, let's say it was mypage.php, what you would see is inside this one document, you would see a mixture of HTML and PHP. So your interface and your logic lived in the exact same place. They were just kind of interweaved with each other. So throughout your interface, you would have little parts where you would flag it as like, oh, this is logic stuff. So you would like put a little PHP flag around it and say, PHP preprocessor, when you see something like this, I need you to run this code. Okay, so pause for a second, run this code, and then keep going until you produce my actual output. Now, for relatively early websites that weren't all that complex, this wasn't a big deal. If your whole interface was 15 lines of code and you had 4 lines of logic in there, we're not really talking about something crazy to manage. But as your websites got more and more and more complex, you could imagine that the amount of HTML in there kept growing. The amount of logic in there kept growing. And now you have those things all piled together. So now we're back into that situation where we're talking about like the procedural languages. You get a big pile of wires and your application lives in there somewhere. All right. So they said, look, it might make sense if we could separate those two And as a developer, we can say, look, right now I'm working on what my interface looks like. So I'm going to work over in this file because this is my interface file. And now I'm going to work on how my application works. That's my logic. I'm going to work on this file over here. And then sometimes you need to get those guys talking to each other. So only in those situations do you have to have a mechanism for making this guy able to communicate with something over here. But they still live in separate places. So you just need to have little phone calls that go between there to keep it simple. Does that make sense? So it makes sense to not have too much of our stuff cluttered together. That's just human sense, right? All right, so MVC suggested that that would be a good idea. Seems to be pretty straightforward, right? Things get too messy putting together, well, you should separate them and then come up with an interesting way of having them communicate so that the human being isn't spending all their time searching for stuff. All right, so PHP initially lacked MVC. Well, it still lacks MVC natively, but there's an infrastructure that's been built around PHP today that has provided solutions for a lot of these weaknesses. Okay, but in any case, in its day, PHP didn't really have this, and it started growing out. What people wanted to do with web pages started outpacing what the technology could do for them conveniently. So they looked for other solutions. So our next thing on the list is Ruby. Do I have a picture somewhere? Do I have it in green? Yeah, Ruby. So we'll change this guy back to blue. We're going to talk about it right now. All right, so there's a language called Ruby. Now, how many of you have ever heard of Ruby before? Okay, a couple of you. How many of you have ever heard of Ruby used without the catchphrase on Rails? You always heard on Rails associated with it, or you've always heard Ruby by itself before? You've never heard of Ruby on Rails? Are you lying? Do another check. Check again. Really? So tell me the context you've heard of Ruby before. So they're using Ruby scripting? Yeah. I could see that being possible. So let's talk about Ruby here. So there's a technology that came out called Ruby. Now, Ruby had built-in support. Well, not even built-in support. It had built-in MVC. All right, so they had their own solution in there for creating your interface in one place and creating your logic in another place. Ruby also had a built-in web server called Rails. So when you hear Ruby on Rails, which is how it's commonly referred to in web programming world, on Rails says you're running Ruby, the Ruby programming language, on top of the Rails server, which knows how to do all the Ruby stuff. Okay? So this came with its own web server, so now you don't have to do the IT stuff. It came with the built-in MVC thing, so you were kind of, in fact, it didn't give you the advantage of being able to implement MVC. Ruby made you do it. Ruby said, look, this is where your interfaces live. This is where your logic lives. That's how it works. You had to do things the Ruby way. So maybe one downside, if we say there's a downside to this, you had to do things the Ruby way. And some of those things, let's say, couldn't be upgraded. Now, Ruby also came with something called gems. So this is a package management tool that allowed you to add additional functionality to your sites. So this is something like if one person wrote something cool in Ruby and you wanted to incorporate that into your site, you could use gems to install that, and now you would have access to that. But what you were not using gems for is to modify the core Ruby structure, which was that MVC thing, which at the end of the day isn't that big a deal. It just doesn't allow competition. So basically Ruby comes out, they said, look, here's how we do MVC. This is how you have to do MVC. Deal with it. And if you don't think this is good enough, go to a different technology, because this is how Ruby does MVC. It's fine. So we might say that Ruby allowed for rapid application development of websites. So RAD, rapid application development of websites in a proprietary way. And you had a couple of competitors with Ruby around the same time that didn't really take over. One of them was called Cold Fusion. If you've ever heard of that from some book somewhere or something like that. But that was one that was kind of a competitor with Ruby, had some of the similar things, didn't really take over. But in any case, if you do web applications all the time, if all you're doing, if your job is to make applications for the internet, for web pages, Ruby is still among the most popular tools. This isn't like this is some dead dinosaur somewhere that isn't being used anymore. In fact, if you've heard of some of these programming boot camps that are out there, like people like, oh, I want to change careers. They go and spend $8,000 or something like that on some 2-month-long boot camp or 6-month-long boot camp, and they guarantee you a job afterwards. And the way some of those work now is the boot camp is free. You make some down payment, and then they take like 40% of your first year's salary, something like that. Like if you get a job, that's when we get paid, that kind of thing. But a lot of those are teaching Ruby on Rails. They're basically producing an army of web developers who are really good at using this tool for making applications quickly. All right. Now, the problem is today is when you think of your average application that comes out, even if it lives on the web, it might not only live on the web, right? You might also have let's just use Slack as an example, okay? So there's a website version of Slack. There's a Windows version of Slack. There's a Mac version of Slack. There's an iPhone version of Slack. There's an Android version of Slack, BlackBerry version of Slack. There's versions of Slack for everything. So those had to be written, at least partially, using different technologies, right? So you couldn't just use Ruby to target all of those. So now all of a sudden you're moving away from that skill set of a Ruby developer. Maybe your average Ruby developer isn't necessarily a long-time programmer, but there's somebody who has learned that programming logic that we're learning in here, well, that we're going to learn in here with the Python stuff, but has also gotten really good at wielding this weapon called Ruby on Rails and can produce stuff pretty quickly as long as they stay within that wheelhouse. Does that make sense? So Ruby's great if you're still a web developer today, but if you're going to start dabbling out into other things, all of a sudden Ruby breaks down real quick. All right. So next thing on the list should be Python. So we'll change this to blue. Okay, now Python's actually a pretty interesting guy because he's danced around on both sides of this. Python is pretty heavily used today as a web language, but it's actually pretty popular in a lot of other things. People are writing data science stuff, big data stuff, artificial intelligence stuff, data mining stuff, machine learning stuff, all in Python. All right, so it's a language that can travel and let you do all sorts of different things with it. And the advantage of it is it doesn't require a whole lot of setup to start using it. If you have a Mac, Python's already installed on the Mac. Otherwise, if you want to write, you can go to a web page and find a Python interpreter somewhere if you just want to write some quick logic to do something. At this point, you're not, many of you have not been programming more than either 0 or, just what you've done in this class. But at some point, programming will become easy enough for you that will be the choice that you'll use to solve some simple problem. So think about, I say simple problem, but think about maybe times in your life where okay, a lot of times it's going to involve some sort of money-making idea where you get out Microsoft Excel and you start putting in things like I make this much, maybe it's your budget, something like that. And you put things in different columns and you have your little formula thing. It's like, oh, do I have anything left over? You have that kind of thing set up. Well, at some point you'll decide that it'll be faster for you to write that in code rather than mess around with all the things in Excel to get it to work right. Does that make sense? I promise you that will happen.
Yeah.
Okay, that will happen eventually. All right. Where if you're doing something relatively quick and dirty and just need to get an answer real quick, it might be quicker for you just to type out 30 lines of code. Because that's not a big deal. You just slap it out and you're done. where, and that's what will change over your 4 years in computer science, or if you go on to grad school, it'll continue going that direction. Is early on, you're going to think programming is really hard. You're going to hate it. You're going to think, oh my gosh, I don't want to do this. I'm going to change majors. I'm going to go become a musician, something else. But then all of a sudden, there's going to be a switch that goes off. And then all of a sudden, programming will become the thing you'd rather do. It's very interesting when you see it through the lower level classes and the upper level classes. Students would rather write papers in the lower level classes because programming is too hard. When you get to the upper classes, there's a crossover where give them a hard program, you could keep your paper. Because the difference is a paper, let's say you have a five-page paper to write. You're not going to like it, but you know if you throw time at it, you can get it done, right? If you throw hours at that, you will finish it. Mm-hmm. Well, when you're first starting programming, if you have the equivalent of a 5-page paper in terms of difficulty computer programming assignment, you might not be able to throw time at it and finish it because you might not have had enough practice yet. So you might throw 100 hours at that 5-page paper and have nothing to show for it in the end. But sometime in the future, you'll be able to throw 20 minutes at that 5-page paper and have it done. You kind of see, that's where it's like a sport thing comes in, where over time you become better and better and better at it, where it's no longer this, it doesn't matter how hard I try, I can't shoot a free throw. Shaq is still dealing with that. So was Wilt Chamberlain, by the way. We've heard of Wilt Chamberlain, right?
Yeah.
Okay. Well, most of the big guys they're too much touch for a free throw for these guys that are 8 feet tall. But in any case, it becomes more of that experiential thing. If you haven't had enough practice yet, then the time it takes to work on something doesn't equate to productivity. Where you guys have been writing for years and years and years, and even though most of you probably don't like writing, you can throw a number of hours at it and produce 5 pages of something. That's C work. Gets through the spell check. Just call that good. All right. So in any case, Python is a kind of a very good language. It's a good programming language anyways, and we're going to start talking about a lot more detail in here, obviously, probably starting next class. Certainly next class, we'll be doing Python the rest of the semester. There's plenty of reasons to teach Python as the first programming language as well. But beyond that, Python takes very little setup. You can just jump to a web page real quick and just do a search for Python interpreter. And you can find a page that'll let you write some Python stuff on a web page. You don't have to download anything to your computer. You don't have to compile anything. You just type some crap into a web page and hit the run button, and it'll run your Python script. That might not be the preferred way of running Python if you're writing anything of size. But if you want to slap something together real quick, just run something real quick, do it right from there. You can download Python interpreters for iPhone or for Android. Interpreters are easier to write than compilers. So if you go on to either the Apple App Store or the Android Google Play Store, you'll see there are plenty of applications out there that will allow you to program in Python. Now, you'll probably find some stuff that allows you to program like in C and Java and things like that as well. But what they're doing is they have to have an internet connection for those. So you're writing the code, it's uploading the code someplace else, it's executing it, and then it's showing you a picture of the output when it comes back down. Where Python can just run right on the device because it's a small interpreter, not a big deal. So it's a very cross-platform type language. So let's talk about Python. I'm going to kind of do this in terms of the Ruby slide. All right, so Python, it did not have built-in MVC, but Python, here, let's actually just go, I'm going to end up writing this all backwards anyways, so let's just delete it. So Python had a tool called pip, okay? And pip is a package manager similar to gem for Ruby, but it also supported third-party tools for things like MVC. So maybe the starting point is Python came with less stuff done for you. They said, here's the language, and this language could be used for web stuff. It could be used for a bunch of other things as well. But here's the language. And then here's this infrastructure called pip that surrounds this language that will allow you to bring in third-party widgets that might help you develop whatever you're trying to develop. So there might have been 10 or 15 different third-party companies out there that made MVC solutions for Python. So you could try them all out, decide which one you liked the best, which one implemented it the best, blah, 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 and that's the one you would use. So a popular, it's called a template engine for Python is something called Jade, something that is commonly used, but there's a bunch of them. You know, that allows you to do your interface in one place and your logic in another place, and it glues them together. But Python didn't provide the entire solution to you. They said, here's a language and here's an infrastructure for bringing in external packages to augment this. So kind of like modding a video game type thing like that. All right. So Python did that. It had plenty of web-ready stuff, but also supports many other technologies having nothing to do with the web. So even today, if you're doing stuff with robotics or stuff with machine learning, there's a pretty good chance that Python might be the go-to scripting language for that. It's a pretty common scripting language for a lot of different things. So knowing Python then allows you to do things for, we have, we're going to have it out on display here, I think, next week. But we have a humanoid robot in the department called the Now, which looks like a person and it can dance around and it's a programmable robot. And you program that thing with Python. It's the scripting language used for Python. They could have picked almost any language, but Python made reasonable sense because it was easy for that company to say, we need a scripting language. Here's Python. It's free. Let's bring that in here and we'll just make it talk to our guy. So they created the tool that allowed it to talk to the robot. And you'll find that example in lots of other places. Amazon Web Services have used their machine learning stuff. Python's the scripting language. So that one skill set allows you to do a lot of different things with that one language. Okay, so anything else I want to say about Python? So really, this is just not web only, so it was kind of a cross-training type language. So let's just jump then to the very last guy. Before I do Node.js, let's talk about JavaScript here. I've kind of left it out here to the side. So we've been talking about the interface on your web pages. So the way your web pages look is done with HTML. So a web page uses HTML for the appearance and uses JavaScript for what's called the client-side logic. So what I mean by that is, let's say that you've put in a username and password on some page, all right, and you hit submit. The thought would be that that's going across the internet somewhere and being validated somewhere as to whether or not that's the correct username and password, and then it shoots back saying everything's good, right? That's something like that's happening. Well, what if you put in the username but forgot the password? You just didn't type in the password and you went and hit the submit button. Would it be efficient for it to send the username and a blank password over the internet, have it check over there, and then send back whether or not, excuse me, have it send back whether or not it was authenticated? Or would it be better to figure out up front that, oh, you didn't fill in all the boxes? It would probably make sense to validate your forms ahead of time, making sure you filled in all the boxes. So JavaScript might be used for something like that. So maybe validating local forms. I'm still off a character. To make sure you filled everything in before sending over the internet. That's just one application of JavaScript. It's kind of the first one. So I'm going to give you a couple more punchlines with it in a second with some other technologies. All right, so JavaScript lets you do some logic in the web browser before you send it to the server. And that's pretty helpful. That's not just it's not just an efficiency thing that means a little. If you have 10,000 people that are all trying to get to the same place at the same time, and they're not sending at least pre-validated data, you're putting a lot more burden on this one central server to make sure that things happened right, when those end users could have had their own browser check to make sure they filled out the form accurately. You know, it's kind of like being at the DMV when you have 500 people in line for the one teller, and they all have their paperwork filled out wrong. And they have to keep sending them back, then people get ticked off and all that stuff, right? So, you know, that's what happens. That's why people get angry at the DMV. That's what happens. So what we'd like to do is have, you know, all that paperwork validated before they ever get in line, so that when they're in line, they know they have something that is actually viable. And now that can be looked at and can only be looked at by that person. All right, so now some other technologies. How many of you have heard of a technology called Ajax? Not the cleaning thing.
Yeah.
It's a technology. Okay. What about jQuery? What about React? What about Angular? All right, so nobody said Ajax, which is actually kind of interesting. So a couple of you raised your hand for jQuery. What's jQuery? Or is it just that we've heard of? Heard of jQuery, okay. So let's go before jQuery and go to look at Ajax. One issue you'd have in early websites is, let's say that you were, let's do this, this will be meaningful to us today. Let's say you were trying to follow the score of a football game, Packers game, something like that, on a web page. Well, today you just sit on that web page and the score updates, right? You couldn't have done that before some of these technologies. You would have had to keep hitting refresh to get the most up-to-date score. All right, so what Ajax did is it allowed a portion of the web page to reload independent of the rest of the page. Otherwise, if you wanted any aspect of a web page to update, you had to update the entire page, allowing that one part to retrieve its information again to get the updated score. Ajax was a technology that allowed you to have one area of the page say, he's going to check in and see when something has changed, and he'll update himself without having to refresh the entire page. And this was a big deal a while ago. I mean, maybe it seems like, well, it's a little bit of an inconvenience today, but consider your web pages today have a lot of pictures and stuff like that on them. Well, our internet connections are a lot faster today than they historically have been. So if you were on a dial-up modem years ago and you had to reload a web page, that might have been a 40-second wait for the page to finish downloading just to get the updated score. You know, and think about how you are right at the end of the games, right? You're not in front of a TV, so you just keep hitting refresh for like 5 seconds. Did it change? Did it change? Did somebody fumble it? Blah, 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 whatever it is. That wouldn't have worked. Your browser would just sit there and paused because it was still downloading from 9 clicks ago. All right, so Ajax was a technology that lets you do that. jQuery did the same thing as Ajax, just better. Kind of an upgraded version of that. Now, React, I'm actually going to talk about React and Angular as kind of being the same thing. React is made by the Facebook people. Angular is made by the Google people. And they basically both solve the same problem. So this allows for push communication to a page. So a page updates when it is told to, rather than when it asks if there is new data. Right? So it does other things beyond that, but let's just keep it the simple thing. So in Ajax and jQuery, you would have to have some sort of thing set up where it was like on a timer. Maybe every 10 seconds it checked for an updated score. Okay. Some of these other technologies, these newer ones, like Angular, whenever there was a touchdown, whenever there was a fumble, whenever there was something that was going to update that scoreboard on the web page, it would get pushed to the web page, and the web page would update instantaneously. You wouldn't have to wait for your page to hit the its next timer alarm for it to check for any new data. That make sense? So a lot of the stuff we have on our pages now are dealing with either React or Angular, that kind of technology, something very, very real time. That make sense? Okay. Now, what's interesting here is every one of these guys, these become kind of buzzwords. So this is something I mentioned earlier in the semester, that in technology, we like to attach all these buzzwords to technology. And a lot of times they mean easy things. So Ajax, jQuery, React, Angular, these all sound like difficulty things, right? The reality is they're not even things. They're not even their own technology. Every single one of these guys is a JavaScript library. They're all JavaScript. So we've had this language called JavaScript that has been validating forms on web pages since the early days of the internet. This guy. And this guy has had things like Ajax, jQuery, React, Angular, and there's even more. These are just kind of the highlights. Born out of it. So what were these guys? You had a whole bunch of people writing stuff in JavaScript. Now, maybe the most obvious use for something like JavaScript would be for validating web forms. Did you put in your username and password before I'll send your data somewhere? Did you put your zip code in? When you get the little red dots on your screen that says, make sure you fill out this form completely before hitting submit, then you hit submit and it screams at you because you didn't put your phone number in the right format, that kind of crap. That's what the kind of common use of JavaScript was at the beginning. Well, so then you had people taking this language and seeing, can I adapt this to other things? Can I do more complex things with JavaScript? Can I hack the web browser to make it do a little bit more than maybe it was what it was designed to do related to JavaScript? So people made a whole bunch of their kind of homegrown applications, and some of them turned into something that other people might wanted to use, like Ajax. So somebody wrote something along the lines of Ajax, and in the end, they decided, oh, well, this is something other people might want to use, and they released it, then it went through a bunch of bug fixes, then it became a standard technology, where people would bring in an Ajax library, and all of a sudden now their web page can have real-time updates without refreshing the whole page. Does that make sense? And all these technologies are just based on this one thing in JavaScript. Well, pretty much based on this one thing. In JavaScript, you have access to the current web page through a variable called document. So you have this one variable called document that houses the current web page. So those four libraries are all about rewriting document in real time without reloading it. That's what they do. So you've had various people, and that's kind of what I said earlier, where jQuery is like a better version of Ajax. So Ajax is kind of a ghetto solution to rewriting that document, where jQuery allowed you, it almost gave you a hierarchical way to step through the document so you can more conveniently rewrite more things on the web page, where Ajax kind of was kind of a one-hit wonder type thing. Reload this one piece. We're happy. Now, what can we do that on? Can we do that on steroids? That kind of thing. All right, so all those things are JavaScript libraries. In fact, you'll probably find if you're in the web developer world, there's probably a 90% chance that any new cool technology that comes out that has some funky name is probably related to JavaScript. It's probably a JavaScript specialty library. Okay? So last but not least, we have Node.js. How many of you in here have heard of Node.js before? All right, any idea what it is? Just it's a thing. It's a newer thing. All right, so an interesting issue we've had historically with web programmers, I kind of mentioned it earlier, is that we have, you have multiple skill sets when you deal with web technology. A lot of times, the people who make the, let's call it the nicest websites, have more of the designer skill set. Okay, maybe they're maybe graphic design, art major type people who then dabble in programming. Okay, and then you have the other side of the thing. We have the people who are hardcore programmers. That's what they do for a living, but can't make something look pretty for their life. All right. So now you have a disconnect. When you go to a web page, the first thing, just like you with eating, right? You eat with your eyes. If you go to the web page and the thing just looks like garbage, you're not going to stay. Right? Unless you're just really, really dedicated, right? The site needs to look reasonable. I mean, fine. So maybe you look at some sites and say, well, this is overboard. But generally speaking, a site needs to look good. It also needs to work well. So typically, you would want to have both of those skill sets. You want to have the designer who can make it look real good, and you want to have the programmer who can make it work real well. Well, the reality is that most web pages, I mean, there's some outliers there, the work well part of it isn't all that complex. It's a whole lot of labor, not necessarily really complex programming stuff. So there isn't a reason why this designer type of person couldn't do that. It's not like they're idiots, right? In fact, many cases, web programmers are more skilled programmers than I've seen traditional programmers be, because they get to dabble in more different technologies. Where traditional programmers say, oh, I like Java, and that's just what they do. So they know a lot about Java. If you have them go outside of that at all, they can't do anything. So the issue would be that your traditional web developer is operating, well, let's call it front end, just to keep these guys a separate. Front end web developer uses HTML and JavaScript. That's their go-to tools. All right, your traditional back-end web developer is going to be using things like PHP or Python to process web forms. All right, so they're going to be receiving that information, reading it in, doing some programming stuff with it. So the issue is that if this front-end person wants to dabble in the back-end world, they're going to have to learn a new language. And that might not be that big of a deal, but if they've been spending years doing HTML and JavaScript, JavaScript is the programming language here that they're familiar with already. Node.js introduces a technology where the backend language is JavaScript. So now somebody, and Node.js does more than that, but just since we're out of time, Node.js at the high level says, look, you can write your front end stuff, your web, your form validation, all that stuff in JavaScript. You can also write your back end stuff in JavaScript. So now you don't have to dance between multiple languages. Get good at this one language. Be familiar with that one language. You can handle both sides of it with that one language. All right. Node.js also brings a whole bunch of other real-time event-driven stuff into it, which is kind of our almost like Angular in React for our web pages, where things are happening kind of without us having to do any updates, but unimportant for us right here. Think about it just that it brings JavaScript as the unifying front-end and back-end language. All right, questions, comments, concerns, bribes. All right, we'll come back on Monday and we will start with Python.